One of the basic ideas behind running a good experiment is that you want to reduce the amount of variation between each experimental unit or subject as much as possible, so that the only variation that each experimental unit is experiencing are the variations that you are dictating they should experience, whether that's, you're experimenting to see how effective a drug is, or just whatever the goal of your experiment is. You want to reduce the variability as much as possible. And that's related to the ideas of control and replication and randomization, all that. So one of the methods that you can use to reduce the variability in your data is by using a technique called blocking. So that's what we're going to talk about a little bit in this video. So when you use blocking, what you do is you split your all of your experimental units up into various blocks. So a block is simply a group of experimental units that are known to be similar. So for instance, perhaps you are blocking based on gender, because you're measuring something where there would be a noticeable difference between the results for men and the results for women. Or perhaps you could block on age. Perhaps if you were looking at younger children, you could block on grade level, something like that. So again, you're trying to block in such a way that your experimental units are going to have some similarities between them. Because again, if they have some similarities between them, then you're reducing that level of variability. So once you have selected your blocks, you are proceeding with a block design in your experiment. So step one, of course, is what we just talked about. Separate your experimental units into the blocks. And then once you have your blocks separated out, maybe there's 2 blocks, there may be 3, just depending on what you're doing. Within each block, you're going to randomly assign each of the units in that block to each of the treatments. So each block is going to get the same treatment. You're not going to vary that. The only thing that's varying is that you are splitting them up into the various blocks. So this is a bit like the stratified random sampling that we talked about in the last section. Again, the advantage of using blocking is that it allows you, or it gives you a way around any unavoidable variability that you're going to see in your data. Again, for instance, if you're measuring something where there would be a noticeable difference in the data for men and women, then blocking on gender would be a natural way to go. So in your book, there was a little blurb that I thought was worth repeating, because this is sort of a cornerstone in good experimental design. You want to control what you can, meaning control as many variables as you possibly can, because of course the whole goal of an experiment is to be able to establish some sort of cause and effect relationship, and you're not going to be able to do that if there's a whole bunch of variables interfering with your data that you haven't been able to control. So control what you can. Then you're going to block what you can't control, because then at least by blocking you can look at the data for each of those separate blocks, and you should be able to note or take note if there is any difference in your data as you were expecting. So control what you can, block what you can't, and then you're going to randomize the rest. And we've already talked about how using random assignments will sort of even out any additional variability that's going to exist within your experimental units.